So in addition to the general and factored form for a quadratic function, another third and convenient way of writing a quadratic function is in what's called the standard or the vertex form of a quadratic function. And that's when we write it as f of x is equal to a times the quantity x minus h squared plus k. And so when we write it in this form, we use the same letter a for the leading coefficient, and that still has the same importance of determining whether the parabola opens upward or downward. So if, for example, a is positive, then the parabola is going to open upward. And this point on the parabola, in this case where the minimum value is, that's what we call the vertex. And so the values of h and k tell us where that vertex is. And this vertical line that goes straight through the vertex, that's what we call the axis of symmetry. And so if a is positive, then the parabola opens up, and the vertex which occurs at hk is going to be a minimum value. And when when a is negative, our parabola opens downward. And in this case, we have a vertex, say over here at hk, and this is going to give us a maximum when a is negative. And again, this vertical line that goes through the vertex, that's what we call the axis of symmetry. So as the name implies, when we have a quadratic function which is written in vertex form, we could very quickly identify where the vertex is and whether that vertex is going to be a maximum or a minimum value. So you can see how this is very convenient to identify the maximum or minimum value of a function. So let's take a look at an example, and then when we're finished with that example, we're going to just summarize what we've seen in all three different forms of a quadratic function: the general, factored, and standard form of a quadratic function. Okay, in parts A, B, C, D, and E, we have 5 different quadratic functions graphed, and based on the properties of the graph, whether it opens upward or downward, where the vertex is located, that's going to identify what the values, what the signs of A, H, and K are going to be. So A, we've already seen. Any parabola which opens upward is going to have a leading coefficient which is positive. So since B opens upward, since C opens upward, and since D opens upward, these 3 parabolas, they all have a positive leading coefficient, and the vertex on each of these is the minimum value of the function. And in part A, this parabola opens downward, so it has a negative leading coefficient. And in E, this parabola opens downward, so it has a negative leading coefficient. And the parabolas in E, A, and E, the vertices in both of these 2 graphs are the maximum value of that function. So to identify the values of the constants h and k, we just need to observe where the vertex is. So in part A, the vertex is located at 0, 0. So the x-coordinate of the vertex, that tells me what h is, and the y-coordinate of the vertex, that tells me what k is. So in this case, since the vertex is at the origin, both h and k are equal to 0. Over here, we see that the vertex occurs at a point that has an x-coordinate which is 0. And the y-coordinate is negative because that vertex is below the x-axis. So here we see that h again is 0, but in this case k is negative because the vertex occurs below the x-axis. Over here, the vertex occurs at a point that on the x-axis. So we see that h in this case is positive because the x-coordinate of that point is positive, and k is equal to 0 since that point sits on the x-axis. In part D, here's our vertex. And since this point has a positive x coordinate, h is positive, and since this point has a negative y coordinate, k is negative. And lastly, in part E, here's our vertex. And this point has a negative x coordinate and a negative y coordinate, so both h and k are negative. So to summarize, the values of the constants h and k are determined on where the vertex is located and whether the x and y coordinates of the vertex are positive, negative, or 0. And the leading coefficient a is determined whether the parabola goes upward or downwards. When it's down, a is negative and the vertex is a maximum. And when the parabola is going up, a is positive and the vertex is a minimum. And so now on the next slide, I just want to summarize what the difference between the general, factored, and vertex forms are. And so to summarize these forms, we started with a general form of a quadratic, which looks like ax squared plus bx plus c. And this was a convenient form because from this we can easily identify when x is equal to 0 that the output y is going to equal c. So this is a quick way to observe, say, the initial value. This tells me that the y-intercept I can see really quickly is at 0c when we write a quadratic function in general form. When we are able to write a quadratic function, say, in factored form, it looks like this. And when we write it in this form, we can see that when x is equal to r, or x is equal to s, y is going to equal 0. So this is a quick way, when we have a quadratic which is written in factored form, we can quickly identify the zeros. We can see that the x-intercepts occur at r0 and s0. And what we just talked about, say, was a quadratic which we can write in vertex form. And when we can write it in this form, we can see that the vertex occurs at the point hk, and if a is positive, the parabola opens up and vertex is a min. And if a is negative, then the parabola opens downward and the vertex is a maximum. So the vertex form is a really convenient way to identify the minimum or maximum value of a quadratic function.